In this video, we're going to be covering work and energy. So an impulse is a force acting over some amount of time to cause a change in momentum. Work is similar to this, but it's with displacement and energy. Work is a force acting over an amount of displacement to cause a change in energy. Now we're going to indicate whether work is done and why not in some examples. So, a teacher applies a force to a wall and becomes exhausted. First, we have to ask ourselves, is work being done? Work is defined as work is equal to FD times cosine of theta, and work requires a force, a displacement, and a force component in the direction of the displacement. A force component in the direction of displacement. A teacher applies a force to a wall and becomes exhausted. So what we know is that the wall does not move. So therefore we know that D is equal to 0. Work is equal to F times 0, which is equal to 0. Therefore, no work is being done. A weightlifter lifts a barbell above her head. The force is upward. And the displacement is also upward. Theta is equal to 0 degrees. W is equal to FD cosine of the angle 0, which is equal to FD. So that's going to be positive work. A waiter carries a tray full of meals across a restaurant floor at a constant speed. Explain why. So, we know the force from the waiter is upward, and we know the displacement is horizontal. So that means that theta is going to be equal to 90 degrees, because the angle between them is going to be equal to 90. Now, cosine of theta is going to be cosine of 90 degrees. Cosine of 90 degrees is equal to 0. So the work done is equal to 0. Therefore, no work is done. A rolling marble hits a note card and moves it across the table. This question is in regards to the marble having a positive, negative, or no work done to it. So we know that the marble slows down. So we know that it slows down. And we know that the force that's slowing it down is going to be opposite to motion. Because it's opposite to motion, we know that it's going to be like this. So in order to find the angle between this, we know that theta is going to be equal to 180 degrees. So cosine of 180 degrees is equal to negative 1. So we know, yes, it is work, but the work is going to be negative. A shot putter launches the shot. Explain why. So we know that when the shot putter shoots the object, we know the force and displacement are in the same direction. So because we know that they're in the same direction, it's going to be like this. So there's going to be no angle between them. They're going to be directly on top of each other. So that means that the work is going to be positive. Theta is equal to 0 degrees. Cosine of 0 degrees is equal to 1. So yes, work is a blank. So we know that it has no direction. And we know that it can be positive. And we know that it can be positive or negative. So that means our answer is going to be D. It's a scalar. And when you have your positive and negative work, it refers to whether the work is being added or removed. Added or removed. So it does not actually have a direction. It has no direction. So it's not a vector. So which set of units represents a legitimate unity for the quantity of work? Circle all correct answers. So we know the definition of work is equal to F times D. That is measured in newtons times meters. Newtons times meters is equal to 1 joule. And we know that 1 joule is equal to 1 kilogram times meter squared over second squared. So that means you can check off joules. Also newtons times meters and foot pound. This is the imperial work unit. Now, on the other hand, kilograms times meters over second That is the units for momentum. And kilograms times meters over second squared, that's equal to force. And then kilograms times meters squared over second squared, that's the same thing as joules. The amount of work W done on an object is calculated using the formula work is equal to the force times the displacement times cosine of the angle. If F is the force and D is also the distance over which the force acts, displacement, and theta is going to be the angle between F and D. So for each situation below, calculate the amount of work that is done by the applied forces. So here we have 100 Newton force is applied to move a 15 kilogram object a horizontal distance of 5 meters at a constant speed. So for this scenario, we have that, which is right here. F is equal to 100 newtons, D is equal to 5 meters, theta is equal to 0 degrees. Cosine of 0 degrees is equal to 1. So work is going to be equal to 100 times 5 times 1. That's going to equal to 500 joules. A 100 Newton force is applied at an angle of 30 degrees to move a horizontal to move a 15 kilogram object at a constant speed of a horizontal distance of 5 meters. So F is going to be equal to 100 newtons. Your D is going to be equal to 5 meters. Your theta is going to equal to 30 degrees. Cosine of 30 degrees is going to be equal to approximately 0.86 if you plug that in your calculator because you want the magnitude here. So work is equal to 100 times 5 times 0.866. So work is going to be equal to 433 joules. An upward force is applied to lift a 15 kilogram object to a height of 5 meters at a constant speed. So we know it's going up. So that means both the F and the D, they're going to be vertical. F and D. That means that theta is going to be equal to 0 degrees. Work is equal to force times the displacement. And we define the force needed. So your force needed to pull anything up, you have to account for the fact that the force is equal to the mass times the gravity. The mass of the object you're trying to accelerate upwards, and g, your gravitational constant. So F is going to be equal to 15 times 9.8, and that's going to be equal to 147 newtons. So now, if you plug that back into your equation for work, in total you have that 147, which is your force, times 5, which is your displacement. It's going to be equal to your total work, so that's 735 joules. Indicate whether there is a positive, negative, or no work that is being done on the object. So we'll just look at whether it's positive or negative work. So when the car skids to a stop, a westward car skids to a stop across a dry pavement. We know that if it skids to a stop, there must be something acting on it that's making it stop. And we know that that force is going to be friction, which opposes the motion. And because we know that it opposes the motion, it's going in the opposite direction of the motion. So let's say work is going, that the work you're doing, your force is going to be here. Your force of friction is this way. And then your displacement is this way. But the angle between that is going to be 180 degrees, which is equal to theta. So when you do cosine of 180, that's going to equal to -1. So that's going to be equal to a negative number. So that's going to be a negative force. Now, a freshman lifts an Algebra 1 book to the top shelf of his locker. We know that the force and the motion are going to be in the same direction. So it's going to be a force that is acting upwards. Your force is upwards. And then your displacement is going to be upwards as well because he successfully moved his book to the top. So that means that it's going to be in the same direction. Therefore, theta is going to be equal to 90. Cosine of 90 is going to, it's going to be the same direction. So it's going to be cosine of 0 is equal to 1. So that is going to be positive. At Busch Gardens, a roller coaster car is lifted the Griffin Tax Peak. So we know that the force is going to be upwards because you're going to the very peak of the roller coaster. And you know also that you were successfully lifted upwards on the roller coaster cart. So that means your displacement is also upwards. Again, cosine of 0 is going to be equal to 1, and that's going to be positive 1. So that's going to be a positive number. A catcher puts out his mitt and catches the baseball. So if he catches the baseball, we know that the ball the ball has to slow down from being caught. So we know that the force, it's going to oppose the motion. So they're going to be in two different directions, and that is going to be an angle of 180 degrees. Cosine, again, of 180 is going to be equal to -1. A falling parachutist opens the chute and slowly falls down. So we know that in this scenario, the ball is going to be going down. The force is going to be going up, and then the person is going to be going downwards, the force of air resistance. So that is going to be an angle of 180 degrees. Again, cosine of 180 degrees is going to be equal to -1. So that's going to be a negative work. So before beginning, most roller coasters are always pulled up at a very high first hill. Work done on the car, usually done by a chain or a motor, is used to achieve this initial height. A roller coaster designer is considering 3 different angles at which to pull the 2,000-kilogram car train to the top of a 60-meter high hill. She measures the following forces required to move the car up the hill over different ramp distances. Which angle would require the least amount of work? Assume no friction. So, for 35 degrees, the work is going to be equal to 1.15 times 10 to the 4. And that's going to be times 105. So that's going to be the same thing as 1.2075 times 10 to the power of 6 times joules. Now for 45 degrees, that's going to be equal to 4 times the distance again. So that's going to be 1.41 times 10 to the 4 times 84.9. And that's going to equal to 1.197 times 10 to the 6 joules. Now here the work is going to be equal to 1.64 times 10 to the 4 times 73.2. So that means the work is going to be equal to 1.201 times 10 to the 6 joules. All right.